I didn't say I wanted to. I say, okay. All right, so what's up, nerds? Welcome to class. I'm sorry I was gone the other day. You asked where was I because you weren't listening. Shame on you. I had a funeral to go to. I didn't want to be there. It's all good, though. It's all good, okay? Look. As far as funerals go, and I'm really good at them. I've had lots of experience. The person they were putting in the ground, very down to earth, okay? It's the best it could be. Nobody? Really? Come on. Nobody? Not awake yet. She was very down to earth. She was very down. They were burying her in earth. Got it. Actually, they didn't. Cremation. But fair enough. It's a weird funeral when they're getting cremated. You know what I mean? It's just like, okay. Right? Do we get to watch? Turns out you don't. All right. I don't know, like Vikings did it. That was cool. So anyway, what's up, nerds? Welcome to Spooktober. Again, fair warning, this is the law. I am allowed to scare you as much as I want during this month. Psychological Scarring Month has started now. Okay? You're going to learn so much, and you'll never forget it. You'll never forget it. Yes, yesterday was Mean Girls Day. Yes. None of you were even alive when that movie came out. Lindsay Lohan was like never wholesome in your lifetime. Ever. All right. Anyone seen Life Size with Lindsay Lohan? And you definitely haven't seen this. With it was their first role ever, I think, on Disney Channel, and it was also Tyra Banks. They worked together. That was a long time ago. We're going to reference the 90s today a little bit. Again, I have warned you thoroughly, right? Good, wonderful, excellent. It's on tape. Today we're going to be talking about this crap. Before we get there, we need to know what we're looking at. What is this nonsense? So, today we're going to learn about corresponding angles. And corresponding angles are these things. I'll show you the definition first. Words are hard, math is easy. It says, definition of corresponding angles. The angles. So we're talking about angles. Okay? These guys seem to have difficulty differentiating between angles and segments. Angles which occupy the same relative position. Relative position. Relative position. At each intersection where a line crosses two others. Okay, well, cool. Relative position. We're going to talk about that first. So same position, right? Nothing shares the same position with you. You have your own position. It is unique to you. If somebody else was in the same position as you, that would get really messy, right? Right? That would get messy. You have the same relative position, though. For instance, you all are in the front row because you're a bunch of frickin' nerds, right? It's frickin' bats. Frickin' bats. What? Nope. Too short of a day. I'm going to do it all formally on Monday. This is a little intro. Good question, though. So frickin' bats. You guys are all in the same front row, so you're in the same relative position, right? Relative to one another, you're in the same position. We're going to learn about relative position versus specific position right now. This is something I did impromptu first hour. It worked, so we're going to stick with it, okay? I have warned you. Here's the fun video. This is the 90s, which none of you are around to experience. But you know what Capri Sun is? Okay, then you're going to understand, right? The old commercials that they used to have was that they would drink the Capri Sun and like literally turn into like liquid, and they would just like float around and do whatever, right? It was like sports, yeah, right? So here is every 90s commercial ever. Here we go. So here we go.
Guys, Cody and the gang are at the park, playing football with Down Darius Jackson.
Let's go! You're not going anywhere without your big game liquid slam.
Excellent!
Go long. This one's going downtown. Whoa!
Whoa! Now I got a full team. Yeah!
Yeah!
Liquid slam!
Liquid slam!
Oh! Jesus Christ! Come on!
Remember that cat.
Oh. Tough day, kids? Well, I've got just the thing. How about some big game pizza pig sticks? Awesome!
Yeah!
Hungry got me
Touchdown, Mrs. D.
Big game pizza, big skins for your taste, but the touchdown. Sack your hunger with Big Game Pizza Pigskins. Pizza that tastes better on a football.
Always use your flamethrower with adult supervision. Football! Woo! Football! Homecoming! Woo! Football! Alright, so there's the uncensored version, the behind the scenes, and then a video featuring Jimmy Kimmel, which is the least funny of all the Jimmys. Oh, now that's a picture. Alright. Liquid Slam.
I love it.
I know, right?
I want some.
Isn't it great? Alright. Excellent album. Kate Nash. Fantastic. Where did the ODS go? There it is. Alright. Inception. No song that exits Friday. Deal with it. Alright. So anyway, when we talk about relative position, we don't mean the same position. We mean that it's similar, right? They have the same, it's something common, right? When you're in the exact same position as someone else, things can get messy. I told you remember the cap, right? Because things that are in the relative position have a theorem. Corresponding angles postulate. It's not really a theorem, it's a postulate, right? We can't prove it. In cap, corresponding angles postulate, if you will, cap, says that if we have two parallel lines that are cut by a transversal, then the resulting corresponding angles are congruent. Well, hold on. What? Let's talk about what a transversal is first. First of all, here are two lines in black and a third line in red. The red line I labeled T for transversal. Okay? So a transversal is a line that cuts two other lines. That's all. That's all. You'll notice that actually all of these lines are transversals, right? This black line right here cuts both the black line and the red line. So all of these are transversals. And then corresponding angles on this transversal would be like 1 and 2. See how they're both at these intersections? Top left corner of that intersection is 1. Top left corner of this intersection is 2. So they're in the same relative position. They're both in the top left corner, right? 3 and 4 would also be examples of corresponding angles because top right corner, top right corner. They're in the same relative position. Smell when I'm stepping in? Okay. When we have a special set of transversals, like this one, when we have two parallel lines being cut by a transversal, then not only do we know that 1 and 5 are corresponding, right, because they're both top left corner of the intersection, but also that they're congruent. Cap says so. Corresponding angles postulate. If we have two parallel lines cut by a transversal, we do. Then the resulting corresponding angles are congruent. So those guys are corresponding, therefore they must be congruent. Same thing with 2 and 6. Same thing with 4 and 8. Same thing with 3 and 7. They just are. And it makes sense, right? You have an angle here, angle 1 and angle 5. They look like they're the same. They should be the same. They're parallel. They're never going to intersect. They're going in the same direction. Therefore, those angles are going to be the same. But we can't prove it. It's just a postulate. Cool? Do you feel like you understand what a transversal is? Sounds like a wrestling move, right? It's just a line that cuts two other lines. That's it. So imagine two lines and a line that crosses them. Transversal. If a transversal cuts two parallel lines, then we know that their corresponding angles are congruent by cap. Corresponding angles postulate. That's all. Notice that if we have a transversal cutting two lines that are not parallel, right? These two black lines are definitely not parallel. Then 1 and 2 aren't going to be congruent. They're still corresponding because they're both top left corners, right? But they're not congruent. Cap doesn't apply. Cool, wonderful, excellent, fantastic. So here's what we're going to do today. We're going to take this diagram and we're going to prove some things about it. First off, we're going to prove 1 and 2 are supplementary. So here's the diagram. Get out a piece of paper, graph paper back there if you want it. We're starting to run out though. We're going to prove that 1 and 2 are supplementary. Yes. Go, go, go. Frickin' bats. It's frickin' bats. It's frickin' bats. Frickin' bats. Happy October, everybody. Look at all those chickens. They can be. Yep. If we ever have time, I will teach you all about ducks and why they are one of the nature's most messed up animals. They are incredibly cute until you know about them. Psychopaths. Other than babies. All right. So we're going to prove that 1 and 2 are supplementary. Now, good news is we don't have to use cap. We don't have to use the new thing. I'm distracting you right now. That way you'll forget what cap is. And I'm telling you I'm going to distract you. And you're still going to get distracted because you guys are all morons. Okay? That's the magic trick. So, here we go. Watch this hand, not this one, right? And you're going to do the thing you always do. So, here's what we're going to prove. We're going to prove that angle 1 and angle 2 are supplementary. Now, you're only given that L and M are parallel. Now, from that information, we're also given one other thing. L and M are lines. When we use that lowercase letter, all it's doing is saving the trouble of having to write the stupid line symbol. I hate the line symbol. Like segment I can do, that's fine. I have no problem with that, but as soon as I put the arrows on, I'm just like, I'm too lazy for that, and I hate you if you make me do it. And so mathematicians are a lot like me, surprisingly. And we can just write the cursive lowercase letter, and that always means we're talking about a line. Okay? So line L and line M is what we have here. Really, when we're talking about angle 1 and angle 2, do we need to know anything about line M? No. Doesn't have to exist. Doesn't matter. So from this information, we don't even care that they're parallel. We don't care about line M. All we care is that line L is a line. So I'm going to write, first off, given L is a line. Now, what does that tell us about angle 1 and angle 2? If L is a line, what does that tell us? I feel like I should play a Kate Nash song here. No, actually, it's not Kate Nash. It is similar to Kate Nash, Regina Spektor, Two Birds and a Wire. We have two angles on a line. Anybody? They're collinear. Yes, that's true. What's the special term we use for two angles, though, that are on a line? Everyone loves saying collinear. There's linear in the name. Two angles on a line. Yeah, Mark. Linear pair. So, because those angles are sitting on a line, and we know it's a line, we just established that, we know that angle 1 and angle 2 are a linear pair. By definition, right? Our definition for linear pair says that if two angles are sitting on a line, they're a linear pair. Right? Now, the last step should always inform the next. Here we said they're a line, so what does that tell us? Well, it tells us they're a linear pair, right? Because they're sitting on a line. Now that I know they're a linear pair, what does that tell us? Do we have a theorem with linear pair in the name? We do, right? The linear pair theorem. So what does linear pair theorem say? What do you think? Yes, ma'am? Are supplementary. Beautiful correction, because it doesn't say they equal 180, because there's many ways to measure an angle, right? But it does say they're supplementary. So by linear pair theorem, by LPT, and again, linear pair theorem says if you have a linear pair, you can say this about them. Well, we know we have a linear pair. We established that, right? So the next thing is saying, okay, so what? So what that they're a linear pair? Well, then, if they're a linear pair, then linear pair theorem applies. And that says that angle 1 and angle 2 are supplementary, which is convenient because that's exactly what we needed, which y'all forgot about. That's what we're trying to prove. Right? That's it. They're on a line, therefore they're a linear pair, and if they're a linear pair, then they must be supplementary. Ta-da! Yes, ma'am. Good. All right, so next thing we're going to do is we're going to prove that angle 1 is congruent to angle 3. Now, so far, our information, all we have is that 1 and 2 are related. We don't know a relationship between 1 and 3. Is there a way we could get some information about angle 3? What do you know about angle 3? Do you see it? What do you know about angle 3? Yes, ma'am.
Vertical from angle 1.
Yes. So vertical angles would be the easy way to be like, hey, look, by vertical angles theorem, 1 is congruent to 3. As of next week, we'll be allowed to do that. And that'll be a nice shortcut. I know, right? But right now we can't. So vertical angles theorem, you know about it. It does not exist in our vocabulary yet. We have not understood it thoroughly and why it is, so we're not going to start using it yet. Okay? So what do we know about angle 1 and angle 3? Yes, or what? That's what I should have said. Yes, and collinear is not what we want to use. Points are collinear. Angles are a linear pair. Okay, at least you could have 12 angles on a line, right? And they would all be collinear because they're on the same line. But the magic happens when we have a linear pair. Just 2 angles making up a line. Okay? So we know that 2 and 3 are also a linear pair. How do we know that? By the same dumb logic. They're on a line because T is a line, right? There's 2 of them. By definition, they're a linear pair. So by the same dumb logic, we know that angle 2 and angle 3 are sub. Same dumb logic as before, right? T is a line, therefore 2 and 3 are a linear pair because they sit on that line. By linear pair theorem, therefore they're supplementary, right? We're just cutting to the chase here. So our last step should inform our next step. Remember, we want to get 1 and 3 in the same equation. Right now we have 1 and 2 and 2 and 3. Let's get an equation. What does this tell you? What is the last step that we just did tell you? What does it mean? Yes, ma'am. Yes, but we can't jump there yet. Why do we know that they're equal? They equal 180, exactly. So by definition of supplementary, they add up to 180, right? So measure of angle 1. Let's measure of angle 2. We'll eventually be able to jump right there, Bailey, but just not yet. I know everybody wants to. And we also know that measure of angle 2 plus measure of angle 3 is 180. And that right there is just by definition. All right, that's the definition of supplementary. We took the last thing and said they're supplementary. So what does that mean? Well, it means that they add up to 180. There we are. And then Bailey said, going a little bit further, that if they both equal 180, then they both equal each other, right? So measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 2 plus the measure of angle 3. And that is by substitution, SUBS. What we did is we switched out 180 for this. See how originally it said it equals 180? Well, I know that 180 is the same thing as this. That's what this guy says, right? Well, if they're the same thing, then you can switch them out, right? If I tell you 5 plus 3 equals 8, you know wherever I see the number 8, I can switch it out for 5 plus 3. It's the same crap, right? So instead of writing 180 here, right, I just wrote what is also 180. I substituted it. I switched it out. Instead of writing 180, I wrote what 180 is. It's angle 2 and angle 3 added together. Right? It's a little weird, but this is more helpful than angle 1 plus angle 2 equals 180, because now we have 1 and 3 in the same equation, right? And that was our goal. So now what do we do to get 1 and 3 on their own? They're in the same room, okay? Remember, the goal is to get them in the same room. If they're meant to be together, if they truly are congruent, if they're really just like together, right? Then you should be able to do math to take care of the rest of it, and 1 and 3 will just be on their own, right? And if they're not, then we prove by contradiction that actually there's not a thing, right? But I think you see it. How can we get them on their own? We got extra people in the room. How are we going to get them out of there? Yeah. We're going to subtract, exactly. SUBT property, right? So I'm going to subtract. I'm not going to use red because that's for my swag boxes. That's why I have so many extra red pens. Whoa. That was rad. Thanks, Danny, for not putting that away, right? By subtraction, SUBT, we subtract angle 2 from both sides, right? It goes away. Yeah. Hannah, calm down. It's just math. Okay. Frickin' nerd. It's frickin' bats. It's frickin' bats. Oh yeah, swag box in red. Getting a little 3D effect there. So 1 is congruent to 3. We did it. Now, the joy of vertical angles theorem is that we could skip all this and just say vertical angles theorem says 1 is congruent to 3. Remember that scissor theorem? Your words, not mine. Where did my scissors go? Oh, yeah, Diana had them. Diana, did you ever give me my scissors back? Yeah. Diana, did you hand them to me?
They're right there. Behind all the pens.
Okay, good. Never hand stuff to me. That's how things get lost. Scissors theorem, right? Yeah, I know. I do that a lot. I bet when you go to the zoo, all the animals want to be fed as well. But do you do it? No, you don't. Don't hand me things. All right, so now we've proven angle 1 and angle 3 are congruent. Cool. Which they are by vertical angles theorem. That's kind of the shortcut there. Well, we can do it without that, right? Theorems are provable. So there should be another way to do it if you forgot the theorem, right? And that will happen to you, right? And so the way to do it is to prove the theorem basically from scratch. All right, so 1 and 2 are supplementary, 2 and 3 are supplementary. Therefore, they equal each other. And if I subtract 2, I get 1 equals 3. Next thing we're going to do. 1 and 5 we know are congruent, right? What allows us to say that 1 and 5 are congruent? How do we know 1 and 5 are congruent? YouTube, remember when I told them that I would distract them, right? Watch this hand, not this one. Yes, Quinn. CAP. The CAP, right? Which you don't remember what it stands for, but you do remember CAP because psychological scarring is a valid form of education. It's corresponding angles postulate. Corresponding means they're in the same relative location. Not the same location, but the same relative one, right? They're both top left. Yes, ma'am. I know. The clock has stopped.
Yes.
That happens sometimes. You what? Oh, exciting. Did you get that hat from somebody, or is that your own hat? Okay, because Danny Mao has the same one. I would be careful, okay? All right, so 1 and 5. You don't want to catch what disease he has. 1 and 5 are going to be congruent by CAP, corresponding angles postulate. If we have two parallel lines, which we do, and the transversal is cutting them, then the corresponding angles that occur because of that are going to be congruent, right? Only when those guys are parallel, though. We've seen before that if they're not parallel, 1 and 2 won't be congruent, right? But when they are, they will be. So 1 and 5 are congruent by CAP. So let's write that. Where did all my stuff go? Here we go. Nope, 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 nope. Oh, it's because I'm out of room. All right, so now we're going to prove angle 1 congruent to angle 5. Well, that's very easy. What are we given originally? What are we given? Dear Lord, help me. Yes. L is a line, and it is parallel to M, right? Now, that's important. If they're not parallel, we can't use CAP. Remember, corresponding angles always occur, but they're only special, right, when the lines that the transversal cuts are parallel, when we have a situation like this, right? This guy, 1 and 2 are still corresponding because they're both top left corners, but they're not congruent, right? Here, CAP says they are. So we know that 1 and 5 are congruent by CAP. Done. Right, that's what they want us to prove. We did it. Awesome. Next thing we're going to prove. Oh, we can do more. We can do more. I want you to prove that 1 is supplementary to 8. That 1 is supplementary to 8. This is what we've been working towards since the beginning. It was the plan. How can we prove that 1 and 8 are supplementary? It has something to do with 1 and 5 being the same, right? They're congruent. There's lots of ways to do it. This is your homework. Prove 1 and 8 supplementary. Write that down, come in with ideas. Yes, ma'am. Oh, absolutely. Yes, I'd love for you to explain it in words. You need to back up everything you do, though, right? This is a proof. We've already established, if you've been following along at home, that 1 and 3 are congruent. We've established that 1 and 2 are supplementary. We've established that 1 and 5 are congruent. How do we show that 1 and 8 are supplementary? We're jumping the pond here. We're jumping from one intersection to the other. And the link, the corpus callosum, if you will, is cap. You guys know what the corpus callosum is? You have two halves of your brain, left side, right side, and the thing that connects them, right, there's a fissure, right, in between them, a grand cut that separates the left side from the right side. And the only thing that connects them is this little thing in the middle, about like this big, right size of your fist, that connects the two halves. And that's the pathway everything has to go through between the left and right brain. For a long time, to treat schizophrenia patients, what they would do is they would sever this thing, completely separate the right and left halves, so they wouldn't be able to communicate from each other. They called this a lobotomy. Terrifying. What they would do is take a long, sharp object and stick it through your eye. Not actually your eye, but your eye socket. I told you it's spooky. It's October. And they would shove it in there, and it would sever that corpus callosum. It is terrible. It is absolutely terrible. Fun fact, my grandfather is the only person to have ever worked with, the only person who has ever been cured of schizophrenia. Pretty dope dude, yeah. Yes, turn your warm-ups if you haven't already. If I have to have nightmares, you have to have them too. It's only fair. Happy October, everybody. The law says I am allowed to scare you as much as I want during this month. It's law. That does not matter to me. None of you do. I have never said that out loud. I have never, ever said out loud that I care about anybody. Tucker, showing up to class early. What a freaking nerd. Come on, boys. Come on in. Everybody else leave. Go away.